Okay, good afternoon, everyone. I'm Angelo Massafra from University of Bologna. I'm a researcher, and today I will present some results of a project we are conducting together with Politecnico di Milano and Università Politecnica delle Marche, both Italian universities. In particular, I will present a research that is titled Topological BIM for Occupancy-based Integrated Energy and Safety Analysis of Higher Education Building. So the focus of the research and the project is occupant-based building management, and it starts from the assumption that on one hand occupancy matters, so occupancy really influences how buildings are used and therefore influence in terms of building management, maintenance, operation and safety issues and so decisions. And that on the other hand occupancy is a quite trendy topic but is still under development in terms of integration both within building science domain, but also and above all with some technical hurdles into integrating occupancy data in common data models above all when we speak about building information model and building performance simulation. Of course, I mean in a standardized and univocal manner. So to include the occupancy dimension in building management, we are advancing the DigitMan project that has two main aims. The first is to develop a digital framework supporting facility managers' decisions according to two different perspectives. The first is the how-to logic, so basically we want to support facility managers in their daily task, making actual decisions. And the second one is the what-if logic, so basically we want to support somehow managers in their strategic management, thinking about the long period of asset management. And in particular, today I will focus on this second topic, the what-if logic, focusing on the development of a workflow and service we are developing to allow the managers, and so to provide a tool to the managers to estimate the impacts of different occupancy scenarios in university buildings in terms of operation, and here I mean specifically energy, but also safety, with specific focus with fire safety. And to do is, we developed this workflow that is based mainly on 4 different phases. The first one is the generation of the BIM model. The second one is the translation from the BIM model to a building energy model to run basically energy simulations. And the third one, is the creation of the building safety model that instead allow to make safety checks on the occupancy scenarios selected for the building. At the end, all these data are integrated into a multi-criteria analysis that allow to evaluate different occupancy scenarios, and again, their impact both in terms of energy need, but also safety checks. And I want to specify from this moment that, I talked about translation of this model, but instead it's better to specify it as jointly generation of the model, but I will specify it in the next slides. So starting from the first phase, the generation of the BIM, we adopted this methodology I developed last year in collaboration with Wasim Jebi from Cardiff University that is called Topological BIM. It's basically a semi-automated procedure to make building information models in a standardized and semi-automated way, modeling the building by spaces rather than components, and generating basically beams that are geometric from the simple from the geometric point of view, but are rich of all of the information that are needed for carrying out many kinds of simulation. And for this reason, they are well suited to BPS applications. Here you can have an overview of the workflow we developed in Python using, above all, almost all open source technologies. But basically the workflow started with the realization, with the making of a simple 3D model representing the spaces of the building. Then its translation into a topological model that can map all the adjacencies between the spaces. Then this model is subject to a conditional data enrichment process that somehow in a semi-automated way allow to assign all the data needed for the simulations, both to the spaces, the walls, the construction components, and so on. And finally, once all the information are within this model, we basically produce 3 different models that basically are aligned because they are generated together and have the same information basically, but that are in 3 different formats. The one is a topologic model, that is an abstract model representing spaces with all needed information, a Revit model that we converted using a PyRevit plugin, and finally an IFC model. Then after creating the BIM model, we pass in the second step the creation of the BEM model, the building energy model. Here we start with the output of the previous workflow, starting with the topological BIM model, in this case in the topologic format. We enable with some tools, always in Python, the zoning of the spaces to produce what we call the spatial BEM, that is a non-AB model relies with on-AB APIs. And then we took the same model, the BIM model, but into the IFC format to translate all the data related to the construction and the spaces and the zones to the energy model. At the end, the energy model is converted to an energy plus model. We add more information about context shadings and occupancy and HVAC schedules. And at the end, we calibrate the model with real data, real weather data, or real indoor temperature data, and do the simulations to carry out some specific calculations and calculate KPIs related to the occupancy rate of main spaces, the energy need, the related costs, and related CO2 emissions due to these hypothetical energy need within the building. In the last phase, we automate also the conversion to a building safety model. In this case, we start with the IFC model, and we produce 3 different graphs. These are spatial graphs realized with Topologic Pi. The first, the passage graph, allows for mapping all the passage relationships between the spaces, basically. The second is the ease-of-use graph that allows to map all the shortest paths between doors of the spaces and final exit doors of the building. And the last one is the skeleton graph that instead allows mapping the evacuation network of the building for making calculation about the width of the main elements, so the corridors, the doors, that of course, as you know, are strongly influenced by the number of occupants that are there. Finally, these 3 graphs are put together into another graph that is the safety model, and this is used to making safety checks about the room, the story, and the building level verification, so in terms of safety. And here you can see some output models of this process. We applied it on a university building belonging to the Politecnico di Milano, where you can see the output of the workflow that was used to produce to enable this jointly generation of 3 different modeling environments. So the topological BIM, the building energy model, and the building safety model. Now we are working on a scenario analysis. So basically, we took these models, and with some APIs, with some Python scripts, we changed the properties within this model. For example, here we can have an overview of the energy model to make calculations and simulations about different occupancy scenarios within the building. For example, we started calculating energy-related KPIs for the current state of the building, and then we started changing things. For example, what happens if I host more occupants in the main spaces, or what happens if I convert all the classrooms to offices, and so on. And now this is related to ongoing work that updates the state of the paper presented for the conference. We are focusing on the last part of the workflow I presented at the start of the presentation, so the multi-criteria analysis. And within this perspective, we are developing an information management framework to keep all these wide variety of information all together in a single data environment. We are working on an ontology for federating data coming from the building information model, from the energy model, and from the building safety model, following a federated approach. So basically, we are using already existing ontologies in our sector to make this federation of ontologies, with the aim of produce a common database, a common graph database, that using some connectors can link all the data I mentioned, so data about the BIM, about the energy plus model, relevant for the energy, and also we will include further integration with the safety model. The final aim will be having all the data within the same data set, and at the end enable data query and extraction from the database to produce a web-based platform, yes, based on some dashboards that allow the users, so the managers, to interact with this data in a user-friendly way, to select, for example, the site, the building, talking and thinking about large portfolios, the scenario to analyze, and also what are the KPIs that he wants to inspect to understand how can improve the behavior of the building. So data in this slide are quite fictional because this is a quite recent update on the project, but the idea is making dashboards for comparing scenarios from different points of view, energy related or safety related. And this is my last slide, is about the future work. Basically, I told today about the right part of this slide, so the multi-criteria microservice that follows a what-if logic, so aim to support future decision making, so strategic planning of occupancy in assets. But other colleagues in the project are working on the how-to logic to integrate real data and also artificial intelligence and machine learning to provide services, real-time services that can support actual decisions in the daily tasks of managers with focus of maintenance problems and operational problems, and again here, energy. So I was a bit fast, but I ended with my presentation, and thank you for your attention.